Hi everyone, in this video we'll be covering number properties basics. Number properties have various subtopics such as fractions, decimals, positive negatives, odd evens, PEMDAS, that is order of operations, prime numbers, fractions, etc. In this video I'll be covering only the properties of numbers. All numbers on the GMAT tested are real numbers. What are real numbers? All numbers on the number line are called real numbers. Example of unreal, imaginary or complex numbers can be iota or under root of -1. Imaginary numbers are not tested on GMAT. To start with, let's speak about integers. Integers are all numbers with no fractional or decimal parts. That is, all the numbers from -infinity to infinity which are not fractions or decimals are called integers. -2, -1, 0, 1, 2 and so on. Whole numbers are the positive integers plus 0. So for example, whole numbers can be 0, 1, 2, 3 up to infinity. All integers, all positive integers including 0 are called whole numbers. Natural numbers are nothing but all numbers used for counting, not including 0. All whole numbers except 0 are natural numbers, or we can say all positive integers are natural numbers. What are rational numbers? Rational numbers are all numbers that can be expressed as a ratio. So for example, any number which can be expressed as a ratio p by q where q is not equal to 0 is a rational number. All integers and fractions are rational numbers. What are irrational numbers? All numbers that are not rational, both positive and negative. Example, pi or minus under root of 3. All these kind of examples where the root is there or the numbers such as pi are there are called irrational numbers. Just to summarize, so all numbers tested on the GMAT are real numbers. Real numbers are divided into rational numbers and irrational numbers. Rational numbers have integers and they have common fractions and decimals. So let us study some of the properties of rational numbers. There are 4 basic properties of rational number. The first property is called as the closure property. Closure property means that a set is closed for some mathematical operations. So for example, if I am adding an integer to an integer, I will get an integer only. This I'll explain in detail in the coming slides. So for example, here we can say that integers are closed under addition. So this is called as the closure property. The next property is called as the commutative property. Commutative property is a binary operation is commutative if changing the order of operands does not change the result. That is, a plus b is equals to b plus a. This is called as a commutative property. Then there is a associative property. It states that you can regroup numbers and you will get the same answers. That is, a plus b plus c is equals to a plus b plus c. Then there is a distributive properties. Tells us how to solve expressions in the form a into b plus c. The distributive property is sometimes also called as distributive law of multiplication. That is, a into b plus c is equals to ab plus bc. Now, why it is important for GMAT to know these 4 properties of rational numbers? Many of the problem solving and data sufficiency problems are around this. We'll see some examples in the coming slides as well. But let's study the closure property, commutative property and associative property for different kind of rational numbers. To start with, let's study the closure property of integers. As I said, the closure property means that a set is closed for some mathematical operations. That is, a set is closed with respect to that operations. If we study addition of integers, -11 plus 6 is equals to -5, which is an integer. 0 plus 3 is equal to 3, which is also an integer. In general, if we add 2 integers, result is always an integer which is in the same set. So the integers are closed under addition. Similarly, if we see subtraction, If we subtract two integers, result is always an integers. So integers are also closed under subtraction. If we see multiplication, if we multiply two integers, result is always an integer. So the integers are closed under multiplication. However, if we divide any two integers, the division is not an integer. So integers are not closed under division. So now let's study the whole numbers. If we see whole numbers, if we add two whole numbers, result is always a whole number. So whole numbers are also closed under addition. Remember, whole numbers are all positive integers plus 0. These are whole numbers. Whole numbers are closed under addition. However, whole numbers are not closed under subtraction. For example, 0 minus 5 is equals to minus 5, which is not a whole number. So if we subtract two whole numbers, it is not necessary that we will get a whole number itself. If we see multiplication, multiplying two whole numbers always gives a whole number. So whole numbers are closed under multiplication, whereas since whole number is also an integer, so whole numbers are not closed under division. If we see fractions, if we add to any rational numbers, if we add any two fractions, the result is always a rational number. Rational numbers are closed under addition. Rational numbers are also closed under subtraction. If we subtract any rational numbers, we get a rational number. Also, rational numbers are closed under multiplication. Rational numbers are closed under division as well. Rational numbers are closed under division as well, with an exception unless divided by a 0. If any rational number is divided by a 0, it is not a rational number. All numbers, whether it is rational numbers, integers, whole numbers or natural number, all are closed under addition and all are closed under multiplication. However, only rational numbers and integers are closed under subtraction, whereas whole numbers and the natural numbers are not closed under subtraction or division. Here if we see division, none of the numbers is closed. Rational numbers are closed under division with an exception of 0. Now let's go to the commutative property. In mathematics, a binary operation is commutative if changing the order of operands does not change the result. Let us see in the table. All the numbers, integers, whole numbers, rational numbers, all rational numbers are commutative under addition. That is, a plus b is equals to b plus a. And obviously, subtraction, if a and b are not equal, then a minus b is not equal to b minus a. All rational numbers are not commutative under subtraction. Multiplication, a into b is equals to b into a. All rational numbers are commutative under multiplication, and similarly all rational numbers are not commutative under division. If a and b are not equal, then a by b is not equal to b by a. We should be remembering that. In summary, addition and multiplication are commutative, whereas subtraction and division are not commutative. Now let's go to the associative property. Associative property states that you can regroup numbers and you will get the same answer. If we see similar way, addition and multiplication are associative for all rational numbers. That is, a plus b plus c is equals to a plus b in bracket is equals to c, or similarly in multiplication. Whereas if we see subtraction and division, they are not associative for rational numbers. For example, a minus b minus c is not equal to a minus b minus c. For example, 5 minus 7 minus 3 is equals to 5 minus 4 is equals to 1, whereas 5 minus 7 minus 3 is equals to minus 5. So all rational numbers are not associative under subtraction, and similarly for division. So addition and multiplication are associative, whereas subtraction and division are not associative. So most of these properties are tested in the data sufficiency questions. However, in the problem solving questions, the questions such as how many integers, how many positive integers such as comes in the GMAT. Let us see an example. How many integers are between 50 and 75? If we have to calculate integers, we simply do number of integers between numbers a and b is equals to b minus a minus 1. That is 75 minus 50 minus 1, that is 24. If the question is how many numbers are between, including, how many numbers are between including 50 and 75, then the answer is b minus a plus 1, that is 75 minus 50 plus 1, which is equals to 26. That is 50 and 75 are also added. So the answer to this question is 24, because it asks for how many integers are between. So just to summarize, number of integers between two integers a and b, where b is greater than a is equals to b minus a minus 1, and number of integers between two integers including a and b, where b is greater than a, is b minus a plus 1. Let us see another example. How many positive 5-digit integers exist? So these kind of questions are common in GMAT. What is the maximum number of 5-digit integer? 5-digit integer, the maximum is 99999. What is the minimum 5-digit integer? 10000. So simply you subtract this 99998. So how many? 89999. You add 1 to it, so you get 90,000. So how many positive 5-digit integers exist? There are 90,000 positive integers which are existing, which are of 5-digit. To find number of positive integers, we do largest 5-digit number minus smallest 5-digit number plus 1. These are the number of 5-digit positive integers. Now let us see a data sufficiency question example. You remember the properties? What were the properties? The properties were closure properties. The properties was commutative, and the property was associative. Correct? So let us see that how these properties are tested on GMAT in data sufficiency. It says if a plus b is equals to c, is c an integer? So this is a question of an integer. Remember, integers are closed under addition. So both a and b are rational numbers. So let's say a is equals to 1, b is equals to 2. Both are rational. So in this case, c is equals to 3, since it is a plus b, it is also rational. However, if a is equals to 1 by 2 and b is equals to 1 by 4, so c is equals to how much? 3 by 4. In this case, c is not an integer. So it is only given they are rational numbers. But the question is asking, is c an integer? We can't determine that it is an integer. So with the data sufficiency question, we always write A, D, B, C, E. Since we can't answer the question alone by statement 1, we strike off A and B. Now let's see statement B. Both A and B are integers. If both A and B are integers, under closure property, C has to be an integer. So the correct answer choice is B with respect to the closure property. Now let's see another example. If A plus B is equals to C, is C a whole number? If A plus B is equals to C, is C a whole number? Both A and B are integers. If both A and B are integers, it is given, but it is not given that both A and B are whole numbers. It is not given. So A and B can also be negative integers. So it is not necessary that C is a whole number. C may be whole number or may not be whole number. So statement 1 alone is not sufficient. So we strike off A and D. Now let's say both A and B are positive. If both A and B are positive, they can be either positive integers or they can be either positive fractions. It is not given that what are they positive. If both A and B are positive fractions, then C is definitely not a whole number. If both A and B are positive integers, then C is a whole number. So statement B alone is also not sufficient. We strike off B. Now let's see both the statements together. Both A and B, if are positive integers, then it is a subset. Positive integers are nothing but whole numbers. So if A and B both are whole number, C has to be a whole number. So the answer choice to this is C under closure property of numbers. Clear? So these kind of data sufficiency question comes where the properties, various properties of numbers are tested. Now let's see the variation of the question. The question is same, that is if A plus B is equals to C, is C a whole number? Here instead of positive we are saying negative. So now let's try to solve this question A, D, B, C, E. So the first statement is not sufficient as we discussed earlier. So now let's see the statement 2 alone, that is both A and B are negative. Both A and B can be integers also, can be fractions also. So the option B alone is not sufficient to answer. Now let's see both together. A and B are negative integers. If A and B are negative integers, so A can be -2 or B can be -3. In this case, A plus B is equals to -5, which is not a whole number. Let's try another. If A is equals to -1, B is equals to -10. Here A plus B is equals to -11, which is also not a whole number. So both A and B together are sufficient to answer that C is not a whole number in case that both statements hold true. So the answer choice is C under the closure property. So that is how the number properties becomes very important in the data sufficiency question. So you should always remember that there is a closure property, that there is a commutative property, and there is an associative property of numbers, of the real numbers which are tested on GMAT mostly during the data sufficiency questions. So thank you so much. See you in the next video.